Blended Podcasts. Brought to you by Blended Audio.
Hello and welcome back to Talos Talks Shit. This is episode 7 in our introduction series.
Not 6.
Not 6, yeah. Puppy.
I've had a count since the last episode.
Yeah, thank God for YouTube, man. Can find tutorials on anything on there. So these next 2 episodes are going to be a little different to our previous episodes. Previous episodes have been pretty technical, pretty focused on specific things. And the reason for that is so we can all have a good groundwork to be working off for when we get into these more heady, deep discussions. So today's episode is going to be a dive into intelligence. Mm-hmm. And a examination of agency and intelligence in the world. And really why that's important is because in our last episode we sort of got up to speed with where neural networks and machine learning and machine or artificial intelligence is at now. So now what people are trying to do is they aren't necessarily solving these simple functional problems as much as they were. They still are, but the problem solving in artificial intelligence has become slightly more esoteric, slightly more broad, and really starts with the problem of agency.
Yeah.
You know? How does an intelligence affect agency in the world? And I don't know if you want to talk a little bit about machines and agency here.
Sure. So, until now, we've been speaking about almost a lot of perceptual problems, right? So, can I look at the world and see the data that's coming in, whether it be image data or sound data, and kind of put it into very specified boxes, right? Or even can I visualize new types of data that are similar, like via the GANs? But we haven't really spoken about acting in the world, right? We haven't really spoken about can machines make decisions in the real world? And there's another type of machine learning. So we spoke about unsupervised learning and supervised
We haven't really spoken about supervised and unsupervised.
Okay.
So to begin this conversation,
Yeah.
we've got these much less brittle, much more capable algorithms and neural networks that are still fundamentally doing a task.
Sure.
You know,
A
predefined task that has predefined parameters, even though they're way broader than a basic checkers playing system.
Yeah.
But these machines are still not choosing where their scope goes. And to begin this scope selection process, there's a process of supervised versus unsupervised machine learning.
And supervised would be some data with a label of what the category or what the correct value is. So, for example, it might be temperature for the day with the correct number of ice cream sales. Right. Or it might be an image with the correct caption or label of what that image is.
Right.
And it's basically what powers anything, well, most things that you see today that have the whole AI
label.
So for example, if your Netflix movie suggestions or your YouTube video suggestions or it's any predictive thing that any company, well, most companies do now, are most probably supervised learning. And what you need for that, and it's pretty hard, you need a lot of good quality data, but crucially that data has to be labeled.
And right? This is, we touched on this a little bit in our previous episodes, but the human cost of AI.
Yeah.
So, for example, a system like Alexa.
Yeah.
Alexa is a voice recognition assistant, and it seems very sci-fi in a way and very capable, but really Amazon has an entire team of mechanical Turks.
Good old Turks.
Dumb machines, aka people, sitting and listening to a lot of packets of Alexa data, specifically packets of Alexa data that weren't correctly interpreted by Alexa. You know, let's say, you say, Alexa, please tell me the geographical location of the Sahara. Right, and it mixed the Sahara up with the savannah or whatever. There's a reason for that. That's a silly explanation, but basically there's a way that Alexa knows to mess that up, and it goes to a human annotation program, and someone sits there and listens and goes, that was actually Sahara, not savannah.
And through good old backprop after the labeled data, hopefully it gets better.
Brilliant, yeah, exactly.
So that's supervised learning.
That's supervised learning, and that still has a very large human cost.
Yeah, and it's basically what powers the economic value of AI today.
Yeah, so that's probably an important thing to note, is that the majority of the time you see anyone touting an AI solution.
My startup has AI.
Yeah, dude, my startup has AI and millions of dollars. It's humans powering that.
Yeah.
Right?
And then there's unsupervised learning.
Right, which is a fairly new thing.
Yeah, and so I don't know if I would say GANs is a version of unsupervised learning, although I think it is.
So I'd say it's a good precursor to unsupervised learning.
And all that unsupervised learning is that it's trying to learn structure from data where the data has no labels. So you could imagine, for example, say you run a vinyl company, right? And you notice that there are 3 types of genres that always get sold. It's like metal, like underground hip-hop, and pop music or something, right? What an unsupervised learning algorithm would do is that it would actually pick up that structure and be like, no one told it, right? So no one said to you, hey, so you're going to have 100 customers coming into the shop today, and they're in these 3 genres. Unsupervised learning tries to learn that structure, from example, from your sales data.
Right, so where this gets interesting is that intelligent machines are going to have access through the internet and through the cloud to massive amounts of data, unbelievable amounts of data. And I think what unsupervised learning is trying to do is that, let's say you've developed the super AI, the AGI, the super consciousness machine, right? And you need to flick that switch to turn it on.
Yeah.
Let's say in flicking that switch to turn it on, you open up the pipeline to all data humanity has ever collected and has ever stored, right? That machine, in a matter of days, downloads all of that data. The unsupervised learning part of this is that how does that machine learn to make decisions based on those massively broad data sets? And I want to ask that genetic algorithm you were talking about in the previous episode, where it decides how many layers it has in its neural network. Would that process would be a step of unsupervised learning?
So I think that, I'm gonna claim Dunning-Kruger here, but I think there's a slight difference between the simulation or an evolution-based algorithm and unsupervised learning. And this is what I'll say. So say for example, you see an example of a Tesla truck, right? And you've only seen one Tesla truck before, and then someday you go to China and then you see a Hino truck, right? You'd still be like, oh, that's a picture of a truck. Or if you'd seen like a caterpillar, you'd be like, oh, that's truck-like, you know? So there are many things in the world that we learn that aren't labeled, right? That we just are able to observe, and we somehow can get structure out of that. right? And that'll be unsupervised learning. Whereas genetic algorithms, what they'll do is that they'll be like, okay, here's a candidate offspring, right? And the offspring might be an algorithm, it might be some neural network architecture, it might even be some optimization algorithm, right? And what a genetic algorithm will do, it'll be like, how good is my offspring? And if I tweaked it a little bit, if I change this or that, how good would this next generation be? So
the data is really still supervised because we have data on genetic evolution and parameters for those genetic.
Yeah. So I mean, think about us. All right, what would happen is that we, like our ancestors, right? Some of them were able to, I don't know, maybe run faster or had better hunting acumen, and that was the signal that, oh, this is a better offspring than something that didn't. And those were the people that were able to reproduce and able to have offspring. And in the same way that the features that they had made them better suited to the environment that they were in, and therefore they were able to procreate, we could imagine some performance measure that our algorithms would have, that if a new generation is good at that, we say that that's a better.
We select for that generation. Yeah. We are the god of evolution in that sense.
Oof, that's pretty terrifying.
Yeah. Okay, so that is terrifying, and that's terrifying for a number of interesting reasons. Because, as you said, you see a Tesla autonomous truck, right? As a human, when you go over to China and you see another truck by another brand that is semi-autonomous.
Okay.
In your head, you have the ability to connect those bits of data. You know what I mean? It's still a truck.
Yeah.
It still drives on the road, and there's still a concept of its autonomy, even though its autonomy is different. You know, this one is semi-autonomous and this one is autonomous. And we tend to take that for granted as human beings. You know, we don't need 10 million images of this is truck, this is not truck to make those extrapolated data guesses, right? And really what unsupervised learning is trying to get at is it's trying to refine that. Because, as we've said, data is a huge benefit, but also a huge problem for AI. It can explode or vanish, you know?
Or vanish.
So, have we got any good examples of unsupervised learning algorithms?
Once again, I would say that I don't want to say GANs are unsupervised learning algorithms, but we do have. They're just very rare examples of where they've worked as well as supervised learning.
Right, so that's another thing. Just because we have these things doesn't mean that they are at the point of good old-fashioned human data input and supervised.
Yeah, so we have some really good unsupervised learning methods, but there's nothing that's so good that it's providing the same economic value as supervised learning.
Okay, but now probably the most important unsupervised learning method is reinforcement learning.
So the reinforcement learning is its own field of machine learning.
Okay, so it's totally separate from unsupervised.
And in fact, reinforcement learning came around the same time neural networks were around. The inventor of them is this guy called, well, not an inventor, but one of the pioneers of the field is this guy called Richard Sutton. And I think he was writing like TD learning and TD lambda at the same time that the deep learning people were doing their stuff. And so TD is just a certain type of algorithm.
Okay.
But what reinforcement learning is, okay, instead of giving this algorithm data, I'm just going to leave it in the world, right? And then the algorithm can make its own decisions. So a classic example of this was, you know that game Pong?
Yeah, for people who don't know, it was one of the first computer games ever. It's super simple. It's 2 lines on either side of the screen and a single pixel ball bouncing between them. And essentially, you just got to move your line so it hits the ball and bounces back like a game.
Yeah, and you're trying to beat your opponent. You're trying to make sure that the opponent can't bounce the ball back.
Like a game of ping pong, but way simpler.
Or like table tennis or
something.
Table
tennis, yeah.
So, what reinforcement learning in this setting would be is that if I give you the pixels of the screen and I tell my agent you have 2 options, right? You can move left or right, by some certain amount, and you can choose what you want to do, right? So in this case, we're not telling it good examples, right? So it's not labeled data because we're not saying this situation you turned left, and we're saying you make the decisions, and that's what reinforcement learning does. And with reinforcement learning, at the end of the game, it'll either win or lose, and that's the signal, right? And you can kind of use not backprop. It's an algorithm. Well, the most famous one is called reinforce, but it's like a certain type of algorithm, and you can sort of give credit assignment to, in this situation, you moved left when the ball was there, and it turns out that helped you win the game. And in that situation, you moved right, and you shouldn't have, and you lost the game. But crucially, the agent makes its own decisions.
That's right.
And it's a big step away from the kind of neural network stuff where we give it data and it does classification. In this case, the algorithm really decides for itself.
Right. And it's important to note that a lot of this is self-play, this concept of self-play. So, just like when you're a child, you sort of wander around and fuck around by yourself, and in doing that, you eat bugs and burn ants and whatever.
Yeah.
And, I mean, excuse the entendre, but you're playing with yourself.
As a 6-year-old.
Yeah, exactly, dude. Started early.
Good times.
Good times. The best times. But this is sort of starting to turn machines into learning mechanisms like humans.
Yeah.
So self-play is a concept of, very broadly extrapolated, how does a child learn?
Yeah.
Child learns by going back and forth. Less times than machine, granted, and that's still a major problem for AI, is that we take a day to learn Pong, they take 4 days, but in those 4 days they play 100,000 games each day.
It's really unfair. It's not like a fair computational comparison.
Exactly. So, and this is, the reason games are interesting for this is because we have no machines that can actually affect physical agency in the world. So the closest thing we have is the Boston Dynamic robots in terms of actual physical agents.
Yeah, but they, interestingly, don't use AI. I mean, I think they're starting, but as of 2017, 2018, Boston Dynamics did not use any deep reinforcement learning, anything. So
how did they train their
They
things?
just have amazing engineers.
Just huge data sets and...
No, so I don't...
Not even...
So I think they just had very complex models of how different parts of the system interacted together. It's just really, really amazing engineering.
Well, this is Boston Dynamics is a unique thing in terms of the advancement of technology, in that it's one of the few places where the hardware is there, in that the robots are really good at running, backflipping, doing parkour, all those terrifying things you see them do, but the software is now catching up, right?
Yeah.
So our only option for actual physical agency in the world is not an option.
Yeah.
Boston Dynamics.
I mean, so OpenAI, which is a company we'll talk about later, they recently released a paper where they were trying to teach a mechanical hand how to pick up a cube and turn the cube so that different faces would look at it. So a cube has 6 faces? I think it's 6. Yeah, 6
Yep.
faces, right? So imagine the faces are labeled 1 to 6, and it'll pick up the cube, and it'll be on face 3, and you might be like, okay, maneuver the cube, so face 4 is looking at you. And so you have to like move your hands in certain ways. And what OpenAI did is that they had a simulator of this. So they simulated it in like a virtual environment, and then they were able to move that to the real world in a very interesting way. But there are very few examples of other companies that have actually successfully done
So
this.
that's very cutting edge, and it's also still the learning happens in the simulation,
Yeah,
not in the
100%.
actual hand in the room.
Yeah.
So that's really why people use video games and games a lot, because games are sort of these isolated package scenarios where you have to make agency decisions, and that can be enacted in a fully digital world. You know, you don't have to have the algorithm outside of the PC to understand a game.
Yeah.
So we now have, and this is going to be the focus of our next episode, I think, in that we can understand that the problem of agency is a key problem in AI.
Yeah.
And to solve that problem of agency, there are a number of methods, unsupervised learning, reinforcement learning, and so on. But the problem of agency then ties into the problem of greater intelligence in general.
Yep.
And there are a few companies such as OpenAI, DeepMind. Those two are really at the cutting edge of this right now. And
there are a couple of companies, but yeah, they're definitely the two most, I would say, publicly foremost respected research companies where they said, oh yeah, we're working on an AGI, people would take that pretty seriously.
Right, well, so for people to take it pretty seriously, in our next episode, we're going to dive a little deeper into DeepMind and OpenAI. We're going to dive into their DeepMind's AlphaGo and AlphaZero algorithms, which were astoundingly good. Mm-hmm. Then we're going to dive into OpenAI's Dota playing algorithm.
Oh yeah, that was a really fascinating bit of work too.
Yeah, and also their natural language processing.
GPT-2.
Yeah, GPT-2, and how the world affects machines and vice versa. We hope you stay tuned. Thanks, as always, to Blended Podcasts and Blended Audio for allowing to host this podcast, Hubby for keeping me straight and narrow, and Alex for doing the magic with the buttons. We will see you next week.
Cheers.
Cheers.